Let's do section 11.3, page 565, exercise 39, which reads, find the slope of the curve at each indicated point. For exercise 39, r is equal to -1 plus sine theta, and the indicated points are theta equals 0 and theta equals pi. Now, if we're supposed to find the slope, then what we really want to find is dy dx, which the book tells us is equal to dy d theta divided by dx d theta, similar to the way things were when we did parameterizations. And the book also reminds us that x is equal to r cosine theta, or f of theta times cosine theta, and y is equal to r sine theta, or f of theta times sine theta. So we can substitute in and figure out what x and y are, and then we can figure out what their derivatives are. So x is going to be equal to -1 plus sine theta times cosine theta. And if we distribute that cosine theta, we're going to have negative cosine theta plus sine theta cosine theta. And now we're ready to take the derivative. So I'm going to have dx d theta, and the derivative of negative cosine theta is going to give me sine theta. And then I'm going to have to apply the product rule. So I'm going to have sine theta times the derivative of cosine theta, which is going to give me negative sine theta, plus cosine theta times the derivative of sine theta, which is going to give me another cosine theta. So dx d theta is going to be sine theta minus sine squared theta plus cosine squared theta. And now we're ready to move on and look at y. So y is again going to be r sine theta, where r is -1 plus sine theta times sine theta. And we can distribute that sine theta, so we've got y is equal to negative sine theta plus sine squared theta. And now we're ready to take our derivative. So we're going to have dy d theta is going to be negative cosine theta. And then I'm going to use the product rule and the chain rule. So when I take the derivative, I'm going to bring this 2 down. So I'm going to have 2 sine theta, and then I have to take the derivative of sine theta, which is cosine theta. So now I'm ready to substitute these two things into my formula. So I'm going to have dy dx, which is going to be, as we said, dy d theta divided by dx d theta. So I'm going to have negative cosine theta plus 2 sine theta cosine theta divided by sine theta minus sine squared theta plus cosine squared theta. And now I'm ready to look at my 2 points, which are theta equals 0 and theta equals pi. So if we let theta be equal to 0, then dy dx is going to be negative times the cosine of 0, which is 1. And this term over here is all going to go away because the sine of 0 is 0. And then in the denominator, everywhere that I have a sine of theta, that's going to be 0 because the sine of 0 is 0. And I'm going to pick up a factor of 1 in the bottom. And so that's going to give me a slope of -1. And when theta is equal to pi, dy dx is going to be equal to, I'm going to have that negative sign, and then the cosine of pi is -1. And again, anywhere that I have a sine theta, the sine of pi is going to be 0. And so in the denominator, again, those terms are going to go away. And for the cosine of pi, I'm going to have -1, but I'm going to square it. So I'm going to get a slope of 1 at theta equals pi.